Hey Stargazers, welcome back. My name is Nick, I'm a theaters manager at the Adler Planetarium, and you're watching Skywatch Weekly. Well, November's full moon is coming up early next week, in the early morning hours of Monday, November 30th. So on Sunday night, and also Monday night, you'll be treated to a beautiful full moon in the sky. Well, something else is happening in those early morning hours on Monday. There will be a lunar eclipse. Now, before you get excited, I want to be clear, this is going to be a pretty underwhelming lunar eclipse. I say that because if you didn't know what to look for, you might not notice much of anything at all. It's so underwhelming, in fact, I'm not going to encourage you to get up early at, say, 3:30 a.m. and go take a look. If it's clear, I'll try and get out there, take a couple pictures. But right now I want to dig into why this eclipse is different. Because don't get me wrong, lots of eclipses are really obvious, super cool to look at, and definitely worth staying up for. This one, not so much. Well, there are basically three types of lunar eclipses: total, partial, and penumbral. With total lunar eclipses, the moon fully enters the darkest part of Earth's shadow, turning deep orange or red as the red sunlight passes through Earth's atmosphere and shines on the moon. Chicago and most of the US saw a total lunar eclipse most recently in January of 2019. The next visible total lunar eclipse for the majority of the US will be in May of 2022. Partial eclipses occur when the moon only partially enters the darkest part of Earth's shadow. In this case, you can see the curved shadow of Earth lying across the moon. Next May, in 2021, the eastern half of the US will see a partial eclipse, and the moon will set before becoming fully eclipsed. For areas farther west, a total lunar eclipse will be visible before moonset. There can also be partial eclipses where no place on Earth experiences a total eclipse, such as the case next November, when only a thin sliver of the moon will remain uneclipsed. This week's eclipse, though, is a penumbral eclipse, and the eclipse is much less noticeable. Only an uneven darkening of the moon will be noticeable if you know just what to look for, and there won't be any clear shadow line cutting across the moon. So why is this? Well, Earth's shadow has two parts, called the umbra and penumbra. The reason for this is that the sun is a disk in our sky. If it were a point of light, Earth's shadow would extend back in two lines with sharp edges. Because the sun is a disk, though, the edge of the shadow is fuzzy. You can see this softening of shadows yourself if you go outside on a sunny day. Notice how all the shadows have soft edges. The darkest part of the shadow is the umbra, and the fuzzy part is the penumbra. Back inside, you can use a small light source, like an LED flashlight, to show a sharp shadow with very little fuzziness. Well, in the case of Earth, its shadow extends away from the sun, and if the moon enters it, part of the light of the sun is blocked. Looking at this event from the moon might help clear this up. If you were standing on the moon Monday morning, part of the sun would be blocked by the Earth. Nowhere on the moon would the Earth fully cover the sun. Now, let's look at a partial lunar eclipse. If you were standing on the moon then, the moon enters the umbra, the darkest part of Earth's shadow. The view from the moon in areas that are in shadow would be a fully eclipsed sun blocked by the Earth. And from Earth, our view would be a partial lunar eclipse. Now, if the entire moon enters the umbra, the darkest part of Earth's shadow, the eclipse is total, and every part of the moon would experience the Earth fully blocking the sun. By the way, the same concept applies for solar eclipses on Earth, when the moon goes in front of the sun. During the solar eclipse across the US in 2017, only a narrow portion of the US could see totality, where the moon fully covers the sun. These areas were in the moon's umbra, the deepest part of its shadow. For other areas, like Chicago, only the penumbra of the moon's shadow reached here, so a partial eclipse of the sun was visible. For areas outside the penumbra, no eclipse whatsoever was visible. Something similar is going to happen next month. On December 14th, there is a total solar eclipse visible for much of South America. But here in the US, the moon will miss the sun completely, and it will be a normal new moon phase. The moon is much smaller than Earth, so its smaller shadow covers a smaller relative area of the Earth. Now, occasionally the moon is farther away in its orbit at the time of a solar eclipse, and it doesn't appear large enough in the sky to fully cover the sun. In this case, the moon's umbra doesn't reach Earth, but in the center of the shadow path, you can experience an annular solar eclipse, where a ring of the sun is still visible around the moon. Eclipses happen in other parts of the solar system too. We've talked before about the major moons of Jupiter, and how through backyard telescopes you can see the shadows of the moons on the cloud tops of that giant planet. You can also see the moons go into or emerge from Jupiter's shadow on occasion. On Mars, the Curiosity rover observed a solar eclipse by the larger of the Martian moons, Phobos, in 2013. These images were taken about 3 seconds apart, and you can clearly see that Phobos isn't round, but more like a potato. So Monday's lunar eclipse won't be particularly spectacular, but now you have an understanding of why that's so, and how a lunar eclipse that's worth staying up for will be different. Now, in the days leading up to the full moon, you can catch some interesting pairings. Tonight, November 25th, the moon and Mars will appear quite close in the sky. And on Sunday the 29th, the almost full moon will be in between the Hyades and Pleiades star clusters in the constellation of Taurus, the Bull. And don't forget to check in on the ever closer pairing of Jupiter and Saturn in the southwest each evening. We're now less than a month away from Jupiter and Saturn's closest visible approach in centuries, and you can catch this little bit of planetary motion in action over the next few weeks. Well, I'll be taking some time off over the holiday, so no video next week. But after that, we'll hit the ground running with more winter constellations visible in the evening, a beautiful meteor shower, and that close pairing of Jupiter and Saturn on the longest night of the year. It's a really exciting way to close out 2020, and I'm looking forward to it. For now, though, that's what we've got for this week. Thanks, as always, for watching. Don't forget to subscribe and also follow the Adler Planetarium on social media. I'll see you in 2 weeks. Happy stargazing.